All right, you guys have been working on this with, I think the buzzing stopped. I turned it off. With a few minutes of class time, let's see what you were able to get. G prime, what does it stand for? The derivative. So both of these are saying the derivative, right? Of G at x equals, right? So the first one is the derivative of G when x equals 0. What's another way of thinking about the derivative, using the description of the derivative? Slope of the tangent line, good. So I want you to look at when x is 0, I should say, I need to update these. When x is 0, what does the slope of the graph seem to be? Remember, a tangent line, it can be symbolized by a straight edge or like a pencil held up against the graph in a way that it would skim the graph. So guys, what kind of slope would a skimming line have at 0? Nobody got it in the entire room? What kind of slope would a tangent line have at 0? Although, what's the awkward part? Why is the answer not 0? Am I looking at his slopes? Why is the answer instead -3? He's a derivative. He's a derivative of G. He's a slope of the tangent line of G. But who's this? Oh, so isn't y equal, oh dear, you guys saw me orient it, I swear. Doesn't this mean that y equals G prime of x is the graph that we're given? Yes. So for G prime of 0, don't I just have to say, oh, I just want your y value, please, sir? Ta-da! So the derivative function's graph is at -3, so the derivative function at 0 is -3. What's G prime of 3 then? 0. Good. So I don't have to think about tangent lines in the sense of looking for tangent lines. If they give me the derivative graph, I just need to find the derivative values, aka the y values. Now what's going on with letter C when it says, what can you conclude about the graph of G? Uh-oh. Now I'm looking back, right? Knowing that G prime of 1 is -8/3. Yeah, something awkward. I don't know. They told me the number. What do I know that G is doing? Or that G has? Did anybody come up with anything? Notes open. Look at the verbal description of a derivative. What are those? If I'm trying to think about not G prime given a G prime graph, but G given a G prime, that's where I think about the verbal description of the derivative function and say, okay, who is the derivative in relationship to his original function? So verbal description, what can the derivative talk about again? Good. So all of those descriptions are talking about in relationship to an original. So that might be something that's helpful for you guys to, where is he? There he is. Slope of the tangent line, slope of the graph at a point, or instantaneous rate. And all of these, we could say the derivative, aka f prime, is the slope of the tangent line to f, or the slope of the graph of f, or the instantaneous rate of f. If I have an f prime, he can be talking about the slope of the tangents to f, or the slopes of the graph of f, or the instantaneous rate of f. So if I'm thinking about the relationship between derivative and what I would call original function, I can use any of these. So you guys basically get to choose. What do you want to talk about if they say the derivative is equal to -8/3? What do you guys want? Which piece of this description do you want to use in order to describe f? You can choose. I don't care. Slope at 1 point? Cool. So let's come over here and say, all right. There were 3 different things that you could have said. So one way is, what can I conclude about the graph of G, knowing that G prime is equal to -8/3? The slope of G at, where? X equals 1 is -8/3. What's something else you could have said? Use another part of the description. Sure, the instantaneous rate of G at x equals 1 is -8/3. What else could you have said?
It's that easy.
Yeah.
Easy if you want to.
What's the third part of the description that we haven't used yet? Good. The instantaneous rate of G is -8/3. Now here's where it gets a little bit snazzy though. How can you have a rate that's negative? Exactly. So what the AP loves is when you don't just say rate of is negative, but instead saying something like, here's probably the best answer as far as in context with an AP free response. You could say that G is decreasing at x equals 1 at a rate of 8/3. Now hold on, so why did I say positive 8/3? Because I used the word decreasing. Yeah. Whenever I use the word increasing or decreasing, I'm always indicating a rate. Does that make sense? Because if something is increasing or decreasing, isn't it changing? And as it's changing, it's like how fast? If it's increasing or decreasing, I'm talking about a rate. So slope is really, really good. It's really, really good for you guys to see a derivative and be like, hey, slope. But it's also really, really good to think decreasing and rate. Is that cool? Or if it was positive, it would be an increasing rate. Okay, letter D. Letter D. What can you conclude about the graph of G knowing that G prime of -4 is equal to 7/3? Doing what we've done, or knowing what we've done in letter C, what would you guys get?
G is increasing.
Sure, we can go straight to the snazzy AP one. So G is increasing at x equals -4. It's actually really important to say that because all we know is one sliver of time, which might be like 4 hours in the past if you're thinking about how could time be negative. But G is increasing at x equals -4 at a rate of, sorry, that's awkward, 7/3. How about letter E? Is G of 6 minus G of 4 positive or negative? How on earth are you supposed to know that? They're asking if the change in G of 6, oh, look at the graph, G of 6 and, oh wait, this is G prime.
Oh, that's
Think about this. And think about this. If the function is decreasing, what's going to happen to its y values?
going down.
As you move forward, they're going to go lower, so a subtraction would be negative. If it's increasing, it meaning G, if G was increasing, what would mean about the y values? The farther you go, the higher they are, so that would be positive. So what you have to ask yourselves is, I wonder what's going on between 4 and 6. 2G in context of this idea. I wonder what's going on as far as whether G is increasing or decreasing. Can I tell that? And if I can tell that, maybe I can answer this question. So guys, looking at the graph of the derivative, what is G doing between 4 and 6? How is he behaving? Why is he increasing? I totally agree.
Because it's going down.
No. G prime is increasing. That's what we can see on the graph. G prime is going up, but that's not what I'm asking. I'm asking what G's behavior is.
Because if you look at G1,
G prime of 1 is a negative. G is decreasing at 1. No, it's not. It's increasing. No. G is decreasing. Why? Because the derivative is negative. The derivative is a negative number. If the derivative is a negative number, then the other dude, G, is decreasing. If the derivative is a positive number, even though G prime is decreasing, if G prime is a positive number, G is increasing. You guys were doing fine when you were looking here. It's hard when you look up here. Now look between 4 and 6. What kind of values, what kind of derivatives, what signs are the derivatives in between 4 and 6? Yeah. So G prime of 4, I don't know, some positive number. G prime of 5, some positive number. G prime of 6, some positive number. All of them are positive. So since all of them would be in this camp, what's G doing that whole time? Since G is increasing, what's going to happen as you go farther to the y values? Well, yeah, they're going to be increasingly higher, so a subtraction is going to be positive. Why? G is increasing. We could say since, because we're snazzy like that. Since G is increasing on the interval 4 to 6. Now, how did I know that? indicated by, how did we figure out G was increasing on 46?
By looking at values.
Values of?
G of 6. Oh.
G prime though, right?
Yeah.
Since G prime of X is greater than 0 on that interval. The subtraction of Y values is going to be positive because G is increasing, so G of 6 is higher than G of 4. We could even do something if you wanted to be super snazzy, like, oh, okay, dun, 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 dun. You could do that if you want to have like a noun to that sentence, otherwise it's kind of awkward. So G of 6 is greater than G of 4, that's why it's positive, since G is increasing on the interval as indicated by the G prime, or the derivative of G, being positive on that. Now, what's the one we haven't answered yet?
F.
Is it possible to find what G of 2 is from the graph? In any of these problems yet, have they asked us what G is at a point? No. They've asked us for behavior. G is decreasing, G is increasing. They've asked us for whether a subtraction is positive or negative, but so far, hasn't it been like very specific but yet ambiguous about G?
Yeah.
It's kind of been like, okay, he's moving, he's changing, how? What can we tell from that? And all of a sudden, letter F gets super specific. Can you find G of 2 from the graph? Anybody know? Long story short? No. I can find G prime values or approximate G prime values. I can tell whether or not G is increasing or decreasing. But in order to answer letter F, we need to know an initial starting point from which we can start thinking about increasing and decreasing from that like initial point. Here's a good example. If you tell someone, oh, I just went 5 miles. Where am I? Exactly. Where'd you start? And which direction? Like, you can't answer the question. From this graph, I can say, well, once we learn more calculus, we can kind of estimate how far the changes are. We can even estimate whether it's increasing or decreasing to the right, to the left, or up, down. But we won't be able to say where you're actually at unless you told us where you started from. Anyway, long story short, letter F. Nope. Explain. It's not a graph of G, it's a graph of G prime, which can tell us how G is changing, but not where G is at. The derivative can tell us how G is changing, right? The description? How G is changing, but not where it's at. Quick reminder, on Friday, didn't we cover a new forever card?
Yes. Sure.
Why didn't I just take down your forevers and say, oh, I need to update? Because this was forever card number 7. Awkward, because that means I added a forever card number 6 that is not online, and it's because it's a brand new card. So I have to figure out how to word it. Then I can give you forever card number 6. Then you can write down forever card number 7. Now, guys, this looks disgusting until you realize what? What's true about these two?
They're the same.
They're the exact same thing, just this one's written a little bit easier, right? A little bit better, a little bit easier, depends on how you look at it. However, from what we did today in the beginning of class, I think for the first time I might add the description on at the end of the card, and here's the reason why. Maybe or maybe not. I forgot what class I told on Friday. But every year I have kids at the very end, right before the actual AP, taking our final, forever final. Who, when asked the definition of derivative, give me some of this stuff. And I'm like, no, this is the description, not the definition. So I might just put them both on the card, and that way it's like you have to be memorizing both of them and distinguishing which is which. But I'm going to make it nice, I'm going to make it pretty, and I'm going to get it on the wall, hopefully by tomorrow. Sound good? Yay. Okay. Some of you guys, I apologize. AP Classroom did something really weird last night. I was doing your bonus and your test reviews, and I heard that it did something freaky and said like you were missing it when you turned it in. Don't stress, don't worry. I just went in there, and I guess I did it on my phone, and it got mad. Long story short. So I went on the computer as soon as Kathleen came in and told me. So now your Google Classroom should be good. I have some of you guys resubmitting stuff. I think it's because you want some points back, but I think I was trying to prove a point with like, hey, you didn't follow the directions, so I probably won't be giving you points back unless it was something where it was missing and so I'm giving you late credit. Or I pointed out something like, hey, you only showed me 3 problems in your pictures. There are some people that, I don't know, they're not submitting all the pictures of their homework and it's really weird, so maybe I'll give them some partial credit. If it's ever something where you resubmit, or you go in and you forgot to hit the turn in button or, I don't know, whatever else, and I've already graded it, like I put a comment on it, I've already graded it, I need you guys not just to resubmit, but post a comment. Does that make sense? Because before the end of the grading period, which is Friday, or actually after the end of the grading period, which is this weekend, I just like search in my email for Google Classroom and I just go through and I make sure I resolve all the comments and everything's been addressed. So some of you guys have some missing assignments, some of you guys, I don't even know. Oh, there are a few of you that something about like it never uploads, come see me with your phone because that's not going to fly for much longer. But those of you that were like, I am so sorry, and then you resubmitted it, that's good and all, and now you know and you won't make that mistake again, but you're probably not getting points back. But if it's something where you think you deserve, rightfully so, some points back on something, you need to post a comment and explain to me what's going on. Sound good? Okay. And if you ever submit something late because you were absent, oh, I don't want to use that example, it's actually quite sad. Something horrible happens and you're not able to do your homework, etc. Like just make sure you throw a comment in when you submit that late also, that way I can kind of judge whether or not you deserve grace. Not that grace should be deserved. Whether I feel appropriate extending grace in that situation. Sound good? Okay. Problem solving strategies, the yellow box. Oh, this sounds fun. Finding the derivative using the definition at x equals a at a particular point x equals a. Huh. If I were you guys on this card when you're doing the title, here's the dealio. This title really sucks. It's a title and it does encapsulate this whole thing because it does include problem solving strategies for this section and for the definition of derivative. But the problem is this one sticks around even after the definition of derivative. So if you guys are when you guys do your title on your forever card number 8, oh, I'm going to have to change all my numbering. This is going to be rough. It's okay, good cause, because I care. Forever card number 8, I want you guys to use f prime of a. Remember, you're supposed to be actually like identifying what it is you're supposed to be studying, and tangent line. Okay, these are the actual titles I want you to use. Not that you can't use problem solving strategies, it's not bad, that's like the overarching, all-encompassing title. But actually put down f prime of a and tangent line. Those are the 2 things this card is about. So f prime of a. How is that different from the one that we wrote down on Friday? That was f prime of x equals a limit as h goes to 0 of f of x plus h minus f of x all over h. So see how much this changes. Ready?
Yeah.
Limit as h goes to 0 of f of a plus h minus f of a all over h. What changed?
Nothing. Fine, x's and a's.
All the x's became a's. Oh, that makes sense, because it's f prime of
A.
when x is a, right? So plug it in, all the x's became a's. Dun, 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 dun. But look at this one.
Whoa.
Whoa! Everything changed. But wait.
There's more.
Isn't it sus? Well, okay, maybe there's a little bit more. But isn't it still a change in y's and a change in x's? But this isn't a change in, yeah it is, remember? Isn't h really delta, sorry, back one more. Isn't, back another one. Yeah. Isn't h really delta x?
Yeah.
So it'd be a difference of or subtraction of x's and a subtraction of y's. So it still fits. It just works a little differently. And didn't we look at on Friday how this one will always be, if you go to plug in, 0 over 0, keep going? What happens when we plug in for these 2? If h is 0, f of a minus f of a all over 0, that's 0 over 0. How about when x is a? Wouldn't that be f of a minus f of a all over a minus a, 0 over 0, keep going? So there's still limits of difference quotients. if we were to go super like geometric and graphically, we would say that they are slopes of secant lines as the removed points get closer and closer and closer and closer to the tangent point, or the point of tangency. Kind of like that blue sheet that we did at the beginning of the year with the parabola. And we were drawing the points and they were getting closer and closer, and those secant lines were getting closer to the tangent line. This is the math of how to do that without actually graphing. So f prime of a. I need you guys to make a quick note of something. Let's see.
Bless you.
Glad you're okay. Why is there a question mark? Bless you, I think. I don't know. I'm kind of disgusted right now. It's so sad. Be nice. Okay, be better.
Oh.
Hi, Maggie.
Why are we
I'm going to say used to identify f of x. In the definition of the derivative, you can look a very specific place, a very specific point, a very specific place to identify the function. And that might not make sense right now. Except, do you guys remember the bonus on your test, which are almost graded? Needed some TA help today from Kylie and John. The bonus was a definition of derivative, right? When I started writing this on Friday, you guys were like, oh yeah, it was on there. Okay. And almost everyone that tried that bonus did it the limit way, minus one person.
Of course, yeah, of course.
I did. I wrote him a little note, like showing off now. Anyway, and he got it, and he aced it, and he didn't solve a limit. What did you do, Adam? Do you remember?
Because in the definition of whatever it is, f of x is isolated, like over there, f of a, and that's what you're really taking the derivative of, so you don't need to look at everything.
So I think 4x squared, was it minus 3x
Yeah.
plus 1? It was something like that. That was the function. And then there was a limit as, was it h going to 0?
Yeah.
Of f of x plus h minus f of x all over h. I think you guys are supposed to do that, right? And so a lot of you guys started like, okay, taking the x plus h and plugging it in and plugging it in and plugging it in and then solving. And a lot of you guys didn't FOIL, you killed puppies, or you didn't distribute the negative, you killed seals, or you just got scared and didn't combine like terms, which was sad. I was like, you were so close. Or you didn't keep rewriting the limit, and so you forgot you were supposed to plug in 0 after plugging everything in and simplifying everything out. But anyway, oh wait a minute, this is like homework. Hold on, we can do this fast. Yes, it was the bonus, but it's also like a homework problem, this section. What if, now, what would be different from the bonus is instead of saying to solve this, we would say, let's find f prime of, just you have to give it a little bit of time. You have to find f prime of x using the limit definition or using the definition of derivative. We would end up with 4 times x plus h quantity squared minus 3 times x plus h. What have I not rewritten that maybe I would get really mad at myself for, or you for doing? Well, I did write it on that side, but what haven't I rewritten?
Oh yeah, the limit.
It's getting darker and darker.
Yeah.
Just wait for it. I don't. Then you needed to go ahead and figure out that was going to be 4x squared, and then it was going to be 2hx times 4 would be 8 xh, whatever that is, and then plus 4h squared.
Where did the 8
Because it's
Oh, you have to FOIL it.
Oh,
So be
X
a squared
plus-
plus 2ab plus b squared. And then that had to be times 4, so 4 times 2 is 8. And then we had minus 3x, and then minus 3h, and then plus 1. But hold on, isn't that all just... Ooh, what am I missing?
Minus f of
Yeah,
Minus-
right? There's just so much. It's easy to get lost, because that was just f of x plus
Lost
h.
in the sauce.
What about f of x? You guys see it? So I still have to do the minus 4x squared, and then the plus 3x. Some of you guys messed that one up. Minus 1 Oliver H. What have I not rewritten?
A limit,
If you don't keep writing it, some of you just lose track of what you're doing, and the AP graders would take off because they say, well, that and this without the limit are two different things. The equals is not appropriate.
Snobs.
I know. And then, not really, they just know that little mistakes can have huge consequences, and they're trying to teach you that. But, some of you then figured out, or didn't figure out, that there was a common H in everybody. So now what? Factor out the common H. And you end up with 8x minus 3. Oh, there's a plus 4h. Sorry, I wrote it out of order. Technically, what was after the 8x was a plus 4h, right? And then minus 3. What can I do to the h's?
Reduce.
Reduce, technically. Some of you, sadly, if you got there, stopped there, but you had to finish. Because now, why is there going to be an equals with no limit?
Because you plug in the limit.
Plug it in, plug it in. So how did Adam write this and get full plus 4 bonus points on his test without doing any of it?
He did the power rule.
He did the power rule from the summer
kidding me?
review packet
Are you
because he
kidding me?
recognized
Are
it
you
was a
kidding me?
derivative.
I thought we weren't allowed to do that. One of the BC kids was like, don't do it, they'll get mad. She'll get mad at us.
On the test, when it said limits, you had to solve it with limits because those were the directions. On the bonus, I think I just said solve or evaluate. So here's the cool thing. On the AP, pause. Didn't I highlight something?
Yes.
On the AP, depending on how it looks, if it's not written in this form where it's like plug it in and solve, but if it's written in a form where you can tell it fits one of these definitions, look in this spot and say, who are you, sir? And if you can figure out who he is on the AP, you can just say, oh, yay, dun, 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 dun. But technically, this is section 2.2, not 2.1, the basic rules and power rule and all that stuff. So I'm just using this forever card to say this forever card is for the entire year. And being able to know you can look here or look here to figure out who is my function and then use your shortcut rule is gorgeous, is amazing, and is necessary as we move on. Kathleen, I'm going to ask you a question as I write down what goes here. Go.
Was the one that we just did on the board, that was the bonus one?
At least it was similar.
Because I remember being
I think it was 8 Maybe I had it written a different way. I might have had it written a different way.
No,
But you were supposed to do a limit of a difference quotient given a particular function.
I just remember it being like a lot more common.
It might have been written out. Maybe it was written out.
Bonus, like all the way at the end.
It was underneath the tangent T over T.
Ugh.
Hey guys, isn't this a line?
Yes. I almost used that.
But wait, what's the tangent line? What's the, oh, if I was trying to find it at x equals c, what would change? Well, c would be my special x, my x1. F of c, if they don't give me what y1 is, and they've given me a function, I can always plug in c and find my y1. But there's one more thing we need to realize. Kiddos, who is the slope of the tangent line? If we are given a particular x of a given function, we can find the slope of the tangent line basically just by using y minus y1 equals m times x minus x1, but the m is always going to be the derivative at the c, not the general derivative, but the specific derivative. Now, oh my goodness, haven't we gone over like, I don't know, 3 different forever cards? Really just 2, but 2 from this section. So where are we at, and why is this homework not due tomorrow? We have some like vocab to talk about, nouns and verbs and adjectives. And we have one more forever card to talk about, but then it's just the rest of our notes are going to be examples. So tomorrow's going to be a big example day. A couple more ideas, but mostly examples. However, this section is solving derivatives with limits, aka summer packet review. Bye guys, go ahead. I'll see you later.
Instead of AKA, you just did like